Hey guys, welcome to AlgoYogi, and the next problem we are going to solve is balanced binary tree. So let's go to the problem, and the description says, given a binary tree, determine if it is height balanced. Height balanced, a height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one. Simply, it's saying uh, the root, if I'm standing on the root, the depth of my left side and my right side, it should never differ by more than by one. So there can be maximum one of the node difference. So if you count the number of nodes in left and in right, they should never differ more than one. The difference should be not more than one. So if it is one, then it's fine, but it shouldn't be more than one. So I don't think we need like a iPad here to just think about this problem. If you know how to find the depth of a binary tree, then at every single point we can just determine if the depth of left subtree and right tree, and then find out the difference. If the difference is more than one, then we just return false, or like have this variable, boolean variable, where we track if we ever found a binary, like if the binary tree is not height balanced. So let's just simply solve it. If you don't know how to find the depth of a tree, I think the problem, you can go back to AlgoYogi, and you'll find this maximum depth of a binary tree that you can follow the link and watch the video there as well. But let's solve it here. So let's keep a boolean variable to see if it is height balanced. So we can call it if balanced, and initially we're gonna say it's true. And you know what, let's use the reference here using our array. Now we're gonna create an inner function, check balanced, which will take the root, and then if root equals to none, it's not JavaScript, so we don't need that, we return 0. Otherwise we get the left. So check balanced, maybe we could call it find depth, and left depth, or left max depth, we can call it. Left depth is the maximum, the depth. We're thinking in that way. So we will call it on find depth on the root dot left side, left subtree, and then we're going to do the same for the right depth. Right depth would be find depth on the right side. Okay, now what I want to do is I want to check the difference, and the way I'll be checking the difference is, let me just add 1 here as well, because that way I'm always, it wouldn't make a difference though, but I'm always checking on the perfect depth of left subtree. Now here, if balanced would be, if balanced equals to I can say just if balanced is, if balanced and my current root is balanced, which would be the difference of left depth, or we can call it maybe like on the absolute because it's returning minus right depth. This is less than or equal to 1. If that's the case, it stays true. If this condition becomes false, that's what the balanced binary tree problem is asking. It returns false. And let's just return the depth here. Return left depth. I think it should be the maximum. Max of left depth and max right depth. Okay, and we can call the function on depth root and then return if balanced 0. Okay, let's try to submit it. If we have done the good job, then it should submit. Okay, and the time complexity would be big of n, where n is the number of node, and the I'm writing it like this, and then the space complexity would be big of h, where h is the height of the tree, or we can call it depth also, the max depth. And these could, in worst case, might be d and n might be equal, or d1 minus n. Okay, so this is done. Let's go back to our AlgoYogi and mark this problem done, and see you in the next problem. Bye bye.